Good night. So this will be a microscopic examination of 3 slides I just prepared. One is just, one is just a semen sample, like stained with methylene blue. I actually, I thought about like taking it only after I kind of already ejaculated into toilet paper. So I used just remnants, and from experience I know it's not good to take it from the toilet paper, because the toilet paper is very, very typically it's very nasty and with all sort of stuff. Like it's so you should know toilet papers are far from being sterile, like not at all. Maybe it's not a problem, just so you know. So I take it, I took it, just, כזה, כאילו, אתם יודעים שיש כזה תמיד כזה צ'ייסרים כאלה, קצת, אז מהצ'ייסרים. עדיף לא לקחת את זה מהצ'ייסר, אלא מהמנה, like from the rocks, but so we might not get like, the best mixture, but anyway, I thought let's take a shot at that. More importantly, we have 2 other samples that are taken from an electrolysis chamber. One stained, one not stained, and if they are interesting, we might try to continue with the energizing stuff, like an energizing effort. I have a really big problem that I have no more slides and no more covers, and even not used ones. And you can't walk like that. I don't have a solution for that. It's not that expensive, but I have nothing at all. It's a shame. Anyway, let's continue. Start with the semen sample. '64 switches 160. Back to 64. These are neos, not bubbles. Sometimes bubbles are formed in similar, I would say, cluster formation, but these are not bubbles, these are actually neos. This guy is moving actually. He's slowly moving. $600 magnification. Lens, dirty lens. What we do see, what we don't see here, and we should see, is sperm cells, because my semen contain both neros and sperm cells together. Now, this can be attributed to several factors. First is that the Israelis are radiating me. They have done so in the past many times, and this called the sperm cells to die, but not the neros. They've done so in the past many times, just radiating the room. Another option is that just it's like that because that we don't see it because of the stain, that maybe they are, I mean, there's something, maybe they don't do well with the stain, I don't know. Made the methylene blue. And there is another option that they just, because I take it, from the last, like, from my experience, it's not like, they're not So we see something actually. Yeah. We see something. Usually you need to use the 600 magnification, like they're small. But usually you see tremendous amount, not like one or two. Maybe it's because I've taken it, from the, as I said, from not from the bulk of like the stream, but from like a remnants, like a squeeze, like a remnants, and because I didn't think like I wanted to, I didn't think about like only after I finished. I thought maybe let's take a microscopic examination. So this could be attributed to that, because you should see tremendous amount of sperm cells. Okay. So it's not as okay. I mean, not a surprise. I mean, pretty standard. So let's continue now. So this is a sample from this container, not colored, not stained. So this mixture is a little too heavy. I mean too dense. It's difficult to focus. Of course we'll see neos, but difficult to focus. It's not a proper slide. This happens many times. Of course we do see neos. I mean, these are all neos. We do see neos. They are just, it's almost impossible to focus with this slide. Just wasn't properly, built. Sometimes it happens when I place too much material or too dense material. Okay. So I've taken another sample from the same container. This one was painted and stained blue. You see it flow because I just, move the cover a little bit, so that's why we see the flow. Now, an interesting question is why are not the neurons moving with the flow, right? Either they are too heavy or because they are floating. You see? What is happening here? So it might be just too heavy or floating? Question. So this slide in the previous one was just not, first actually I'm taking it from the top layer that is heavy with foam and probably many metallic, like residue from the poles. So it's probably very, very dense and not suitable for backlight microscopy. I should have taken for quite some time. I'm not I'm not doing science in the last couple of months, so just practical stuff that like technical stuff, like how-tos, like small how-tos, kind of like that it was part of my life, for something like a year that I've done so almost every day, but I kind of forgot about it. Like and if you should have taken like something from, I should have noticed that the foam like on the top is very, very dense, probably with oil and metallic particles, galvanized particles. So I should have taken it from the deeper layers. So I'll watch these slides and I'll see how maybe I can create like new slides, because these were not probably created. And although the covers, there is a limit to how much you can wash it, because before it's like becoming like so maybe instead of like glass covers, I will use sellotape. It can be done. It was done in the past. Like I didn't have a proper covers initially, so I used just sellotape. So it's not the proper way, but it's better than using used covers, because they are quickly becoming like dirty in the fact that you cannot watch through it. So it's not okay. So I'll prepare new slides, and maybe what I'll do now is I'll use for the energy transfer, because we've seen here also. Maybe you can think about energy transfer. So the idea is to take a little bit of what we have here, place it inside another container, metal container, and then maybe add a little bit of water or a little bit of pee. I also prepared pee, but so the overall quantity will be very, very, very small. And prepare a slide with sample from that small container. That way, the same. The resistance will be much. I admit I don't have, I mean, admittedly I don't have like the accurate terms like to explain how it will affect the electrolysis, because there are several, like, you know, factors here. But for certain, what we know for certain is that, I mean, it's not certain completely, but I mean, intuitively, there will be much less resistance between the two poles. So this will allow more flow intuitively. You know, just V equals IR. But this is oversimplification. But we'll go for that for now. I mean, we'll go with that for now.